So, our team has been assigned by Chemtech. Chemtech decided to use hydrogen peroxide H2O2 fueled drones, known as Quadrone, for efficient sample transportation between Block A and Block B located in South Korea. Distance between Block A and B is 3.2 kilometers and the squadron has a speed of 10 km per hour, but it will cease its movement once the concentration of H2O2 reach 0.004 molarity. So, our team has been assigned by Chemtech to determine the initial optimum H2O2 concentration for successful sample delivery and to avoid wastage of H2O2. The surroundings temperature is also considered as the environment in South Korea has 4 different seasons, which means 4 different surroundings temperature. To successfully tackle this problem, it is essential to have a clear understanding of chemical kinetics and how concentration and catalytics impact the decomposition of H2O2 as explained by the collision theory. Chemical kinetics is the study of the rate of reaction and factors that influence these rates. It provides insights into reaction mechanisms and dynamics. The reaction rate is directly proportional to the frequency of effective collisions between reactant particles.
The problem at hand is to determine the optimal initial concentration of the hydrogen peroxide in a drone for efficient propulsion, considering the variation of temperature which will affect the kinetic energy under different seasons in South Korea. The initial concentration of H2O2 plays a crucial role in the drone's performance. The kinetic characteristics of H2O2 decompositions are known to be influenced by environmental factors including temperature and humidity. So it is essential to investigate and understand how the kinetic behavior of H2O2 decomposition changes in different seasons to establish appropriate initial concentration that optimizes the drone's propulsion system for safe and efficient operation throughout the year at the Chemtech Research Park. Our objective is to determine the initial concentration of H2O2 to be used for the transportation of squad drone across the Chemtech Research Park in South Korea. The research is also conducted to evaluate the effects of temperature on the initial concentration of the drone. And so, this is what we are going to do.
First, we need to understand what are the factors affecting reaction rate. The factors are temperature, concentration, and catalyst. In the simplest form, the temperature of a reaction directly affects its rate. When the temperature increases, the reaction rate also increases. This is because the temperature influences the energy of the reacting molecules. Higher temperature provides more energy to the molecules, making them move faster and collide more frequently. These collisions are necessary for a reaction to occur. At lower temperature, on the other hand, the molecules have less energy. Therefore, when we consider the Maxwell-Boltzmann distribution, the speeds of the molecules are lower and the distribution has a smaller range. As the temperature of the molecules increases, the distribution flattens out. The concentration of reactants affects the reaction rate. When the concentration of reactants increases, the reaction rate also increases, and vice versa. When the concentration of hydrogen peroxide increases, number of molecules per unit volume will increase, which eventually increase the frequency of collision between molecules as well as the frequency of effective collision between molecules, and hence, the rate of reaction will increase. Platinum has been chosen as the catalyst to use in the drone due to its efficiency. The catalyst will lower the activation energy for the molecule as it provides an alternative path with lower activation energy. By reducing the activation energy, a catalyst increases the number of reactant molecules that can successfully collide and react. This means that a great proportion of the reactant molecule will have enough energy to overcome the lower energy barrier and proceed with the reaction. Hence, the rate of reaction will increase. Now, let's delve deeper into the calculation.
So, firstly, you need to identify the rate constant. But how?
Okay, first of all, it is given that the final concentration is 0.04 molarity, which the squadron will stop. There are some steps to find the initial concentration for each season, which has different temperatures. First of all, we need to conduct an experiment in spring to determine the data of concentration with time. From that data, we can plot 3 graphs of concentration versus time. Then, by using the graphical method to determine what order of the reaction. After we draw 3 graphs, 0 order, first order and second order, then we pick the graph with best fit line and the highest correlation. as the order of the reaction. How about you, Sashwin?
As you can see, the first is the best fit line and the highest correlation. Amongst all, thus, the decomposition of H2O2 is the first order reaction. Therefore, the slope of the best fit line graph or gradient is the rate constant K in spring. Recall, South Korea has 4 seasons, which in summer, spring, winter and autumn. Summer we have 27 degrees Celsius, winter we have -6 Celsius, autumn we have 20 Celsius and spring we have 18 Celsius.
Okay, now we can determine the initial concentrations to be used for the drone during the spring. So how? Use equation of first order. So we just plug in the rate constant K and then plug in the final concentrations, which is 0.004 molarity, and the time calculated, which is 2304 seconds. Then we can find the initial concentrations of hydrogen peroxide in spring. So we're done for the spring. So what about other seasons? First, use the Arrhenius equation to determine the rate constant for summer, autumn, and winter. Next, with the available K, we can calculate the initial concentration of hydrogen peroxide during summer, autumn, and winter. And then how? Use the equation of first order. So that's all. We can find all the initial concentration for all the seasons.
At high temperature, the rate of reaction will increase. The system will favor high temperature, which means the kinetic limitation is at low temperature. The decomposition of hydrogen peroxide is an exothermic reaction which gives the value of delta H as negative. Meanwhile, the delta S value is positive due to decomposition of liquid hydrogen peroxide to oxygen gas, which is more disordered. Based on the Gibbs free energy equation, the value will always be negative, which means that the reaction is spontaneous at all temperature, and hence there is no thermodynamic limitation. So, in summary, the research conducted at Kinetic Research Park has successfully achieved its objectives by determining the optimal initial concentration of hydrogen peroxide H2O2 for efficient propulsion of drones. The study considered the influence of temperature variations across the 4 seasons in South Korea on the kinetic behavior of H2O2 decomposition. By leveraging the collision theory and chemical kinetics principles, appropriate initial concentration were established, ensuring safe and efficient drone operation throughout the year. The research outcomes paved the way for the implementation of H2O2 powered drones with platinum catalyst, offering improved two-way mobility and resolving the limitations of traditional transportation methods within the park. With the optimized initial concentrations, the drones can achieve constant speeds, cover significant distances, and stop at the desired concentration. This research provides a solid foundation for practical implementation, revolutionizing transportation in the Kinetic Research Park with a sustainable and efficient solution. The obtained initial concentration values for each season ensure year-round operational excellence, making the H2O2 powered drones a reliable and effective means of sample transportation between Block A and Block B. So I think that's all from us. Thank you. Bye-bye.